So hello my colleagues, and I do hope everyone is well. So the last video I made, we kind of left off at this example here, and I want to go over this example where you're going to evaluate monthly cash flows, okay? And there's some interesting points we're going to make here. The first interesting point is I had to have a sip of my coffee since it's 5:26 in the morning. Oh, well, let's look at this problem, all right? So suppose your bank account pays interest monthly with the interest rate quoted as an effective annual rate of 6%. So it's an annual rate of 6%, right? But they're going to pay you interest monthly. What amount of interest will you earn each month if you have no money in the bank today? How much will you need to save at the end of each month to accumulate 100,000 in 10 years? All right, so this is an effective rate of 6%. So we use equation 5.1, which we show here. Okay. And we use it right here, and you can see we take 1.06, we put the annual rate there, to the 1/12th power. We got to get the monthly rate, okay? Because it says here it pays interest monthly. So you notice how they put a fraction, 1/12th, okay? And they subtract 1, all right? So this gives us an interest rate of 0.4868% per month. Okay? So we can write the timeline right here this way, and here's our cash flows, right? And why do they have 120? Because it says 10 years times 12 months is 120 payments. So you're going to save at the end of each month. Okay, so I'm jumping ahead to a concept we didn't teach, but this is an equation which you'll get to eventually, and we will get to it. But I want to just tell you what it is. This is basically telling you right here how much of future value would you have in an annuity, and you all understand what I mean by annuity. Okay, annuity is an amount of money that you're putting in every month. So you're putting in so much money here every month. That's an annuity. And if you retire, you would get an annuity. Like Social Security is an annuity, right? You put money in every month, and then when you retire, you get money out. So here's the future value of the annuity. Here's the equation, and again we'll go over that. So here's the periodic payments you make, and here is the number of periods, and here is the interest rate. Okay. So we're going to solve for them. What we're going to solve for is we want to know how much of a monthly payment we have to make. All right, we got to solve for C because that's what they asked for, right? How much monthly payment do we have to make to accumulate? We want this to be what, $100,000, right? You see, this has got to be 100,000. It says in the example. All right, so we got to solve for C, and this was equation 410 in the book. So you can go back and review that. But we will get to that and talk about that in more detail. So we do solve for the monthly payment, C, and we use this equation, and all we do is put up here 100,000, and you do a little jockeying with the math, right? 100,000, and here's the monthly interest rate. Remember, you have to do apples to apples. Here's the monthly interest rate. And here is the number of periods, and it comes out that you have to put $615.47 a month in the bank, monthly, and at the end of 10 years you'll have $100,000. Okay. So they show you how you could do this in Microsoft Excel. Okay. And I'm going to possibly try to do that right now if I can get this to work right. So 120.4868, present value is 0, and you solve for, there's a payment function in Microsoft Excel, and here's the future value. Let me see if I can bring that up. All right, so I don't want it. I need to get the numbers right. So why is it doing that? All right, let me see if I could. Let me see if I can memorize. So we're gonna use. You go up here and you click on f of x. You see this f of x? This has got all the built-in Excel functions. And why it's not opening is a mystery to me right now. I'm trying to get the f of x to open. All right. Hold on. I'm gonna pause. Okay, I'm back. So I got it to open. So you notice up here I do a search for the word payment, PMT. Okay, and then I say go. And there's the payment function. First of all, there's a lot of built-in finance functions in Excel. Okay. And I say okay. And it brings this up. Okay. And I'm going to show you how you can make your life like very easy. So if I put 6%, first of all, watch carefully how I type it. 6%, it knows to make it 0.06. Okay. And I'm going to divide that. No, I'm not going to do that. I'm going to write 6%. And the easier way of doing that is just put the effective rate. Let me find the function. Hold on here. It's better to do that. 0.4868. So I got to put the monthly rate. I almost forgot. 0.4868%. Okay, you see how it puts it there? And it's going to be number of periods. So it's 12 times 10 years. So I put 120. All right. Now I have no money. It said I had no money in the bank. Okay. And what I want to do is accumulate $100,000, right? And there's the number it comes up with. Now you notice it's negative, but it comes out to your answer, right? 615.47. Now you see yours is negative and mine is, and it's negative because that money's got to come out of your pocket, into the bank every month to accumulate 100,000. All right. So that's how easy that is. If you ever have any questions, we'll be spending a lot of time with Microsoft Excel. If you have any questions, let me know. All right. So that's how easy it really is. The only question you gotta have, and again, this is built right into Excel, and I showed you that, right? The only thing you got to remember to do is use equation 5.1, because they tell you this is an effective annual rate of 6%, and you got to get the monthly rate because everything's got to be done with comparing apples to apples. Okay, so I wanted to make that clear to everybody. All right, let's see how this video plays out, and again, I hope it works.
Valuing monthly cash flows using an EAR quote. The thing to remember about interest rate quotes, effective annual rates, and in a few moments we'll see the annual percentage rate, is that these are interest rate quotes. They do not necessarily correspond to the actual interest earned. From these quotes, you need to calculate the actual interest rate earned. And in this example and the following example, we demonstrate how to do this. So in this example, the bank is paying monthly interest rate, but has quoted this as an effective annual rate of 6%. What an EAR quote means is if you take the actual interest rate the bank is paying, so let's call that R, and you roll the investment over every month in the account, so you do not take your money out, at the end of the year, you will have earned 6% over the year. So solving this formula, we get that the actual interest rate earned is 0.4868%. Okay, so we want to put a fixed sum away each month for the next 10 years so that the At the end of 10 years, we will have $100,000. We begin, as we do all problems, by writing out the timeline. In this case, it's going to be in months. Next, we go to the last chapter and look up the formula we derived for the future value of an annuity. Taking this formula, we rearrange terms so we can solve for the cash flow in terms of the future value. We can now use this formula to solve for the monthly payment, which turns out to be $615.47 per month.
Okay, so I hope that was clear to everybody, and it kind of reiterates what I said. All right. So I want to show you an interesting point here, and they talk about a common mistake using the wrong discount rate in the annuity formula. All right, the discount rate period must match the periodicity of the cash flows in the annuity formula. In example 5.1, because the cash flows, and again, apples to apples, monthly, we first must convert the EAR into a monthly discount rate. A common mistake in this case is to treat the annuity as a 10-year annual annuity with a discount rate equal to 6%. That's crazy, right? Doing so, we would get that each month we would put away over $7,500, which is the amount you would need to invest per year, not per month. So this would give you the rate. Again, now we're doing this from an annual standpoint. See that? Because this is an annual rate. Note also that if we try to convert this to a monthly rate by dividing by 12, we get 632.23, a higher amount than we need according to example 5.1. The reason we can save less is that by depositing the cash monthly rather than at the end of each year, we will earn interest on our deposits throughout the year. So you got to be careful how you approach these. Okay. Okay. So I'm gonna cut this off for now, and I'll pick up in the next one. Happy New Year to everybody.